Imagine trying to build a rigid iron cage to trap the wind. You can weld the bars as tightly as you want, but the air simply slips right through. Right now, that is exactly what global efforts to regulate artificial intelligence look like. The brightest lawmakers and computer scientists on Earth are racing to build a regulatory framework for this technology, but they're discovering that they are welding their bars in completely the wrong places. Artificial intelligence now functions as a borderless global infrastructure, one that is already starting to dictate labor markets, national defense, and the global economy. Treating this fluid network like a traditional local industry is setting up a direct collision between global technology and fractured human laws. To see why this is so difficult, look at this comparison between nuclear materials and code. On the left, a physical lockbox holding uranium. On the right, an AI model weight, the digital parameters that define its intelligence. Physical threats like enriched uranium are secured inside concrete facilities that can be inspected by the UN. But an AI model is a digital file. Once training is complete, those weights can be duplicated and transmitted to a server halfway across the planet in seconds. Applying 20th century physical non-proliferation treaties to a digital idea is an approach designed for a world that no longer exists. So how do you contain an idea? The first strategy is the tech fence. Engineers use alignment techniques like reinforcement learning from human feedback, or RLHF, to train polite, ethical guardrails directly into the software. But these software guardrails act more like superficial masks. Researchers consistently find that users can use adversarial attacks, or jailbreaks, to bypass the filters and expose the unrestricted capabilities hidden underneath. Because the software itself is too slippery to contain, regulators are pivoting to a much blunter strategy. They are trying to starve the hardware. Advanced AI models require thousands of specialized GPUs to process their data. The United States is working to create a silicon chokepoint by strictly limiting who is allowed to buy these chips and the lithography machines required to make them. This is a deliberate geopolitical tool. The US government is using the global supply chain to throttle the computing power available to rival nations. While controlling the physical hardware puts a strict bottleneck on development, the strategy is brittle. It relies entirely on a single coalition maintaining an absolute monopoly over global chip manufacturing. While the US leverages hardware, other regions are relying on the legal fence. The European Union recently passed the AI Act, attempting to build a comprehensive legal fortress. Instead of worrying about the hardware, the EU classifies AI by the danger it poses to citizens, outright banning systems like social scoring, while placing heavy compliance burdens on applications like hiring algorithms. Then there is the approach from the BRICS coalition. They are engaging in a strategy of controlled proliferation, imposing strict domestic censorship, while simultaneously releasing models with hundreds of billions of parameters to the global community to bypass Western controls. As a result, the US, the EU, and the BRICS nations are writing contradictory, thousands of pages long rulebooks for the exact same technology. And just as global lawmakers are finalizing rules based on the electricity required to train a model, the technology has shifted shape again. As the node pulses, labs are moving toward test-time compute. Instead of relying entirely on pre-training runs, newer models like OpenAI's o1 can allocate processing power to reason through complex problems after the initial training is finished. This breaks the logic of almost every current regulatory framework. Most laws use strict training compute thresholds to identify which models are dangerous. If a smaller model can achieve frontier-level intelligence just by thinking a little longer during the test phase, auditing its birth is no longer enough. We now have to figure out how to govern its thoughts. This graphic outlines 3 futures for the rest of the decade, showing what happens when rapid AI advancement collides with regulation. In scenario A, proliferation wins out. Open-source models bypass hardware choke points, driving down costs and making high-powered AI as common as electricity. In scenario B, consolidation takes hold. Compliance costs and export controls shut out the competition, resulting in a market controlled by a handful of the most well-capitalized labs. Finally, scenario C is stagnation. Punitive regulations and competing state laws crush innovation, causing researchers to leave for more permissive regimes. These geopolitical shifts can feel overwhelming, but navigating a fractured, AI-saturated landscape doesn't mean you have to wait for governments to figure it out. First, you can diversify your own digital toolkit. Understand the difference between relying on a locked-down corporate model and running open-source software locally. Second, learn to look for provenance. Standards like C2PA act as a digital paper trail, allowing you to trace an image back to its source and verify reality in a flood of synthetic content. Third, maintain human oversight. As AI agents become more autonomous, they still lack genuine context and lived experience. Your judgment is becoming the most valuable asset in the economy. The trajectory of artificial intelligence is defined by the choices we make today, not just in halls of government, but in how we choose to integrate these tools into our own work.